Hello my friends and welcome back to the Today Machine channel. Franchini Acciai, established in 1968, stands as a global leader in modern forging. Hello my friends and welcome back to the Today Machine channel. The production process begins with the meticulous selection of raw materials. Franchini sources ingots made from carbon, medium alloy, and stainless steel exclusively from certified European steel manufacturers. The ingots undergo rigorous evaluation to ensure the correct chemical composition, tailored physical properties, precise metallurgical characteristics, and optimal geometry. Depending on the intended application, selected ingots may involve advanced secondary metallurgy processes such as vacuum degassing, vacuum oxygen decarburization, or electroslag remelting. In the cutting stage, ingots are resized to fit subsequent manufacturing steps. Franchini's cutting area is equipped with 20 hacksaws capable of handling materials with openings up to 3,500 millimeters, alongside a burn table that can handle thicknesses up to 1,500 millimeters. This capability ensures that raw materials are efficiently prepared for forging. The core of the operation is the forging department, which houses 3 fully automated presses and next-generation manipulators, offering a combined forging capacity of 100,000 tons annually. These highly flexible and automated lines enable the efficient production of forgings tailored to meet diverse industry needs. Following forging, the components undergo heat treatment to achieve the desired mechanical properties and microstructural integrity. The heat treatment area is equipped with advanced furnaces and quenching tanks, facilitating processes such as normalizing, quenching and tempering, solution annealing, and stress relieving. Each heat treatment process is carefully monitored by skilled personnel to ensure precision and consistency. Franchini's well-equipped machining shop includes CNC lathes, milling machines, boring machines, deep drilling units, and machining centers. This extensive range of equipment allows the company to deliver both rough and finished machined components, catering to specific customer requirements. Finally, inspection and testing are integral to quality control. Every stage of production is meticulously supervised by trained experts to ensure compliance with industry standards. The dedicated test and inspection department conducts thorough evaluations of raw materials, blank forgings, and finished products, ensuring reliability across all applications, from nuclear to oil and gas sectors. Operating from 2 expansive production sites in Italy, covering over 150,000 square meters, the company maintains a production capacity of 50,000 tons per year. The workshop specializes in supplying high-quality forgings to various industries, including energy, petrochemical, naval, steel, and mechanical sectors. Varel manufactures high-performance drill bits for the mining, industrial, and oil and gas sectors. The process begins with the design phase, where proprietary software is used to create fixed cutter and roller cone drill bits tailored to specific drilling applications. The company utilizes advanced materials, including cutting structured body materials and gauge protection. Varel tests PDC and tungsten carbide cutters in its technology center to maximize the rate of penetration and durability. The bits are produced using precision CNC technology and heat treatment machinery, ensuring consistent product quality. The production process of Ruco core drills begins with loading the machine, where raw materials such as HSS or TC are prepared. Next, the spiral flute is ground precisely, followed by grinding the cutting edges to ensure sharpness and durability. This step is critical for achieving optimal cutting performance in various applications. Finally, each core drill undergoes strict quality control, where precision and tolerances are checked. The production process results in 165,000 core drills annually, each designed for specific applications such as steel, cast iron, and high alloyed materials, ensuring superior performance and reliability in demanding environments. Elwood City Forge, headquartered in Elwood City, Pennsylvania, is a global leader in open die forging, with over a century of experience in producing high-quality forged products. The company works with a variety of materials, including carbon, alloy, stainless, tool steel, and nickel alloys. Steelmaking involves a stringent refining process that results in clean steel ingots with the precise chemical properties required for further forging. The workshop operates 5 large presses, capable of handling forgings up to 110,000 pounds, 57 feet in length, and 94 inches in diameter. Following the forging process, parts undergo heat treatment before being sent for machining, which includes turning, milling, boring, blasting, welding, and fabrication. With facilities in Pennsylvania and Ohio, the company serves industries such as oil and gas, power generation, aerospace, shipbuilding, and the military, delivering high-quality products. It begins with the arrival of copper billets, which are precisely cut to size before entering a gas-fired preheating furnace. The billets are heated to optimal temperatures to prepare them for shaping. A 50 meganewtons extrusion press forms the billets into tubes, which are then subjected to a cold drawing process to achieve desired dimensions and mechanical properties. The tubes pass through a 30-ton drawing bench and spinner blocks for precise adjustments. These stages ensure the consistent quality and structural integrity of the tubes. The tubes are transported using a basket transport system, leading to the coiling process, which produces 600 kilograms level wound coils. An automatic guided vehicle system efficiently moves these coils to subsequent stages. Heat treatment furnaces are used to tailor the tubes to specific application requirements, ensuring optimal performance for industries such as air conditioning, refrigeration, plumbing, and electrical applications. For HME industrial tubes, the process includes additional treatments to meet sector demands like fittings production and solar thermal applications. HME plumbing tubes are customized for domestic plumbing, heating, and sprinkler systems. Finally, tubes are wrapped in protective plastic film, end capped by robots, and packed for delivery. At the HME copper tube plant in Mendon, the production of Tech tube and Sancor tubes for industrial and sanitary applications involves a highly efficient and automated process. The electric kettle production industry in China has witnessed substantial growth over the past decade, driven by increasing domestic demand, a burgeoning export market, and advancements in manufacturing technology. As of 2024, China dominates the global electric kettle production market, accounting for approximately 80% of global output. Production scale and distribution. The annual production of electric kettles in China is estimated to exceed 300 million units, with a significant portion destined for export. Guangdong, Zhejiang, and Jiangsu provinces are the primary manufacturing hubs, collectively responsible for more than 70% of the country's output. These regions benefit from established supply chains, skilled labor, and access to ports, enabling efficient logistics and reduced production costs. Export market. China exports electric kettles to over 120 countries, with the European Union, the United States, and Southeast Asia being key markets. In 2023, China's export revenue from electric kettles surpassed $5 billion, reflecting a compound annual growth rate of 7% over the past 5 years. Domestic market dynamics. Domestically, the Chinese electric kettle market is valued at approximately $3 billion, driven by rising living standards, urbanization, and increased demand for energy-efficient appliances. Middle-class households and young consumers favor smart electric kettles with features like temperature control and app connectivity, leading to a surge in the production of premium models. Technological advancements. Chinese manufacturers are investing heavily in automation and smart technology to enhance production efficiency and product quality. The use of stainless steel and food-grade plastics has become standard, and many factories employ robotic assembly lines capable of producing up to 5,000 kettles per day. Additionally, innovations in energy efficiency and smart features are enabling manufacturers to meet global sustainability standards. Key players. Leading companies play a pivotal role in shaping the industry, contributing over 40% of total domestic production. These companies leverage economies of scale, strong R&D capabilities, and extensive distribution networks to maintain their market leadership. Challenges and opportunities. Despite its strengths, the industry faces challenges such as rising raw material costs and stricter environmental regulations. However, the shift toward green manufacturing and the adoption of smart appliances present opportunities for growth. With robust production capabilities, strategic export markets, and continuous innovation, China's electric kettle production industry is poised for sustained growth, cementing its status as a global leader in the sector. The roller door production industry in Taiwan is a robust and export-driven sector, blending advanced manufacturing techniques with innovative design. Taiwan has established itself as a global hub for roller doors, with exports accounting for approximately 65% of total production. The industry generates an estimated $1.5 billion annually, with key markets including Southeast Asia, Europe, and North America. Over 300 manufacturers operate in Taiwan, predominantly small and medium-sized enterprises. The sector benefits from a well-integrated supply chain, which includes suppliers of galvanized steel, aluminum, and high-performance coatings, ensuring quality and durability. Around 60% of roller doors produced are motorized, reflecting a growing preference for automation and smart technology integration. Domestic demand for roller doors is fueled by the construction and industrial sectors, with a 5% annual growth rate reported over the past 5 years. Exports have grown steadily, with a 7% year-on-year increase in 2023, driven by rising demand for secure and customizable solutions. Taiwanese manufacturers prioritize R&D, investing over $100 million annually to develop lightweight, energy-efficient, and weather-resistant products. They are also adopting green manufacturing practices, such as the use of recyclable materials and energy-efficient production processes, aligning with global sustainability trends. The industry's ability to innovate and meet international standards ensures its continued competitiveness in the global market. Recycling copper from refrigeration equipment is a highly effective and environmentally sustainable process. The recycling process begins with the dismantling of refrigeration units, where copper components are carefully separated from other materials such as aluminum, steel, and plastics. This is typically done through mechanical processes or manual labor, ensuring copper is not contaminated with other metals. Once the copper is separated, it is shredded and then smelted at high temperatures to remove impurities, a process known as refining. The resulting high-quality copper can be reused in the production of new refrigeration systems or other copper-based products. In the U.S., it is estimated that about 1.5 million tons of copper are recycled annually, with a significant portion coming from the disposal of old appliances, including refrigerators. The recycling of copper from refrigeration equipment alone can contribute several 100,000 tons to this total. This not only conserves valuable resources but also significantly reduces energy consumption. Recycling copper saves up to 85% of the energy required for primary copper production, making it a vital component of a circular economy. Additionally, for every ton of copper recycled, up to 1.2 tons of CO2 emissions are avoided, further underlining the environmental benefits of recycling. Copper, being one of the most widely used metals in refrigeration systems, is integral to heat exchangers, condensers, evaporators, and piping. Approximately 50% of copper used globally is recycled, which is crucial in reducing the need for primary extraction and minimizing environmental impacts. The copper anode production process involves a series of advanced steps to refine copper from concentrate and recycled materials. The raw material, including copper concentrates and recyclable materials, is received at the facility, with nearly 740,000 tons of concentrates annually containing between 10% and 40% copper. These materials are handled with precision through various stages, starting with strict quality control and sampling to ensure the correct copper content. The next step involves processing the concentrate in a Noranda reactor, a technology developed in 1973. The reactor operates at 1,200 degrees Celsius, where the materials are exposed to oxygen-enriched air to separate sulfur from copper. This results in two phases: the slag, containing iron, silica, and 4% copper, and matte, 70% copper. The matte is transferred to a Noranda converter, where it undergoes further oxidation at high temperatures to produce metal with 80% copper purity, known as metal blanc. This metal blanc is then subjected to additional purification stages to reach 98% copper purity. Following this, the copper enters desulfurization vessels to remove any remaining sulfur. The refined copper, now at 99.1% purity, is finally cast into molds to form anodes, which are cooled and solidified. Throughout the process, sulfur is captured and converted into sulfuric acid, a valuable byproduct. The facility also processes the slag to recover any remaining copper and precious metals. The copper anodes produced, rich in precious metals like gold, silver, platinum, and palladium, are transported to refining plants for further processing, ensuring that every step of the production chain contributes to high-quality copper production. The upcast SG tube continuous casting technology revolutionizes the production of thin-walled copper tubes by delivering heavy coils ready for direct processing. The upcast SG tube process produces copper tubes with a grain structure suitable for direct processing on tube drawing machines. Since the cast tube is already near its final dimensions, the need for extensive intermediate processing steps is eliminated. This approach is highly adaptable, allowing for customization based on the final product size and requirements. Applications and materials. The primary application of upcast SG tube is the production of thin-walled phosphor deoxidized copper tubes used in sanitary, industrial, air conditioning, and refrigeration systems. It is also compatible with other copper grades and alloys, offering broad applicability. Core components. The upcast system comprises a furnace system and a casting machine tailored to customer needs. A charging system for cathodes or recycled copper and specialized coilers complete the setup. Raw materials. Copper cathodes are the preferred raw material for oxygen-free copper production due to their high purity. Recycled copper scrap, though usable, requires extensive purification and separate melting to ensure quality. Furnace configuration. Single furnace. Ideal for outputs up to 12,000 TPa, combining melting and casting in one unit. Double furnace. Suitable for up to 40,000 TPa, separating melting and casting functions. Triple furnace. Accommodates both cathodes and recycled copper for maximum flexibility. Casting machine. Multi-strand systems with individual coolers ensure precise control and high productivity. Simultaneous casting of different rod or tube sizes is facilitated by modular coolers and computer-controlled servo systems. This method bypasses numerous costly steps typical in conventional tube manufacturing, significantly enhancing efficiency while maintaining flexibility and environmental sustainability. Available in a hybrid configuration, it optimizes capacity for both copper cast rod and tube production. China is a global leader in the production of copper molds, a critical component in continuous casting technology used extensively in the steel manufacturing industry. The country's dominance in this industry stems from its advanced manufacturing infrastructure, cost-efficient production methods, and robust domestic demand driven by its vast steel industry. In 2024, China's copper mold production capacity was estimated to exceed 150,000 tons annually, accounting for nearly 60% of the global market share. This substantial output serves both domestic and international markets, with exports comprising around 25% of total production, supplying countries in Asia, Europe, and the Americas. Key players in the industry include CCM Group, Shanghai Electric Group, and several mid-sized manufacturers located in industrial hubs such as Jiangsu, Hebei, and Shandong provinces. These manufacturers specialize in producing copper molds for various applications, including square, rectangular, and round billet casting, with a focus on high-quality copper alloys like chromium zirconium copper to enhance mold longevity and performance. The industry's growth is fueled by significant investments in research and development. China's copper mold manufacturers have adopted advanced production technologies, such as vacuum casting, precise CNC machining, and advanced coating techniques like nickel and chromium plating. These innovations enhance the thermal conductivity and wear resistance of copper molds, critical for improving the quality of steel output. In 2023, the market value of China's copper mold industry was estimated at $1.2 billion, with a compound annual growth rate projected at 6% from 2023 to 2028. This growth is attributed to rising steel production, which reached 1.013 billion tons in 2023, alongside increased demand for specialized molds tailored to produce high-grade steel products. Environmental concerns have also influenced the industry, with leading manufacturers implementing green production practices, such as recycling scrap copper and adopting energy-efficient technologies, aligning with China's carbon neutrality goals for 2060. The high-speed coil production process at preformed windings ensures rapid and precise manufacturing of coils for high-voltage motors and generators. The process begins with copper of the highest electrical quality, subjected to rigorous testing before entering the production line. A state-of-the-art looping machine is employed to produce coil loops up to 9 meters long, while automatic shaping machines form coils with exact precision. These machines store coil shapes in their memory for future identical production runs, enhancing speed and consistency. Insulation systems such as resin-rich, unpressed resin-rich, and vacuum pressure impregnation are applied to the coils, ensuring optimal fit within the stator slot, which maximizes performance and longevity. Extensive quality checks, including earth testing, tan delta, and partial discharge tests, are integral to the process, adhering to international standards and ensuring the highest levels of performance. Preformed windings focus on rapid response is exemplified in their Qual Coil Rapid service, which delivers coils in just days rather than weeks. This efficiency is facilitated by their newly invested production facility, optimized flow, and highly skilled workforce. Splicing 1-1/2 wire rope is a technical process that requires precision, expertise, and specialized equipment. The task begins with careful preparation of the wire rope. The ends are measured, marked, and cleaned to ensure the strands are free of debris, oil, or rust. This step is crucial to achieving a secure and durable splice. Next, the wire rope is unlaid or separated into its individual strands. The riggers carefully manipulate the strands, ensuring they remain intact and undamaged during this process. The goal is to weave or interlace these strands into a strong, seamless connection that can withstand the high stress of heavy loads. A common method for splicing large diameter wire ropes is the hand tuck splice or a mechanical splice using swagging. Hand tuck splices involve manually weaving strands over and under each other to create a secure joint. This method demands exceptional skill and patience to ensure uniformity and structural integrity. Mechanical splicing, on the other hand, employs hydraulic presses to compress a steel sleeve over the rope, creating a solid and reliable bond. Throughout the process, the splice is inspected for consistency and alignment. The final step is testing the splice under load to verify its strength and safety. This team of expert riggers excels in this intricate process, ensuring every splice meets rigorous standards. Their precision and attention to detail ensure that the finished product is not only durable but also capable of performing in the most demanding applications. The hydraulic cylinder manufacturing and revision industry is critical for sectors such as construction, marine, mining, agriculture, and heavy machinery. Below is a detailed analysis of each segment. Hydraulic cylinder manufacturing and revision. Hydraulic cylinders are crucial components for converting hydraulic energy into linear mechanical force. In manufacturing, cylinder sizes range from small, 20 mm bore, to large-scale cylinders exceeding 1,000 mm bore diameter and strokes up to 10,000 mm. Materials used for cylinder barrels include precision steel tubes with a typical hardness of 60 HRC and chrome-plated piston rods for corrosion resistance and durability. Surface roughness is controlled to raw as less than or equal to 0.2 micrometers to ensure smooth operation. In revision, repair and refurbishment, processes involve disassembly, cleaning, inspection for wear or damage, honing the cylinder bore, replacing seals, and chrome plating the piston rods. Load and pressure tests up to 700 bars are conducted to ensure the cylinders meet OEM specifications before being returned to service. Engine cylinder covers. Engine cylinder covers are vital for large industrial engines used in marine, power generation, and heavy vehicles. These covers endure extreme pressure and temperature conditions, often exceeding 250 bars and 350 degrees Celsius, respectively. In production, cast iron or alloy steel is commonly used, with precision machining ensuring proper sealing surfaces and critical tolerances within plus or minus 0.01 millimeters. Refurbishment includes crack detection using dye-penetrant or ultrasonic methods, remachining of sealing surfaces, and replacing worn-out components such as valves and injector seats. Specialized CNC machines are used to ensure that critical dimensions are restored. Pump renewals. Pump renewal services target hydraulic and mechanical pumps used in various industrial applications. Key types include gear pumps, vane pumps, and piston pumps, capable of handling pressures up to 450 bars. During refurbishment, worn-out parts are replaced, and precision grinding ensures that tolerances are maintained within plus or minus 0.02 millimeters. New pump components, such as impellers and casings, are often made from stainless steel or bronze, depending on the application. Testing protocols for renewed pumps include hydrostatic pressure tests and flow rate checks, ensuring performance meets or exceeds ISO 9001 to 2015 standards. Industry outlook. The global market for hydraulic cylinders, engine components, and pumps is projected to grow at a CAGR of 4.5% from 2025 to 2030, driven by increased demand for reliable heavy machinery in infrastructure projects. Companies in this industry focus on innovation, including the use of robotic welding, automated assembly lines, and digital testing systems, to improve production efficiency and quality. Furthermore, sustainable manufacturing practices such as recycling metal waste and reducing energy consumption by 20% are gaining traction. This workshop has operated a state-of-the-art rolling mill with a maximum rolling capacity of approximately 260,000 wheels per year, capable of producing wheels up to 1,450 millimeters in diameter. All wheels are manufactured using high-quality steel from the Lovere plant steel mill line in Italy, ensuring consistent metallurgical improvements and custom steel grades tailored to specific customer and operational needs. Chain production begins with carefully cleaned and prepared wire. The wire's length and bending are precisely controlled, with each link seamlessly joined. Advanced welding techniques eliminate the possibility of weak links. Every chain undergoes uniform processes, followed by heat treatment to enhance toughness and resistance. Surface finishes like sandblasting, electro-galvanizing, or eco-friendly lacquering provide a distinctive touch. Rigorous quality tests for bending and braking ensure reliability. Finally, secure packaging guarantees safe global shipping. The glass bottles production process begins with a carefully measured mix of silica sand, soda ash, limestone, and recycled glass, or cullet, which can make up to 70% of the mix in some regions. These raw materials are melted in a furnace heated to 2,850 degrees Fahrenheit, a temperature exceeding molten lava. A typical furnace produces 10 tons of molten glass per hour, feeding it into a refiner to achieve the precise consistency and temperature needed for forming. The molten glass is divided into measured gobs, which are delivered to forming machines. These machines shape the glass using molds, where compressed air sculpts the material into a variety of sizes and designs. With production running continuously, millions of bottles are formed daily. Once shaped, the bottles are transferred to an annealing layer, where they are reheated and slowly cooled to room temperature to relieve internal stresses, ensuring strength and durability. Rigorous quality checks follow, testing for size, shape, strength, and color. Imperfect bottles are recycled back into the furnace to start the process anew. Finally, the flawless bottles are packed into pallets, ready to support food and beverage brands worldwide. Precision Foundry is renowned for manufacturing high-performance engine-quest cast iron cylinder heads through a multi-step process that ensures top-tier quality. The journey begins with CAD modeling, where the design is carefully crafted to meet precise specifications. Next, pattern making and core placement take place, where the mold for casting is prepared. Core making involves creating the internal cavity structure necessary for the cylinder head. While core pack construction ensures stability and accuracy during the casting process. Once the mold is complete, it is assembled and left to dry. The next critical step is pouring, where molten metal is carefully poured into the mold to form the cylinder head. After the casting cools, trimming is performed to remove excess material. The cylinder head then undergoes 5-axis machining for precision shaping and detailing, ensuring optimal performance and fit. Detailing and decking refine the surfaces to exacting standards. To ensure reliability, the cylinder head undergoes several tests. The pressure leak test checks for any leaks in the components, while the vacuum test verifies its sealing integrity. Chamber volume testing ensures consistency in engine performance, and the valve install height test measures valve seating. Lastly, the valve guide tolerance is carefully checked to guarantee the highest precision and performance. In ball bearing production, the process of placing the balls inside the bearing races is achieved through a specialized machine. The bearing races, which consist of an inner and outer ring, are first formed and prepared. The machine uses an automatic feeder system to precisely place the balls into the race. It positions them in evenly spaced pockets around the circumference. Once the balls are loaded, the machine secures the races and seals the assembly, ensuring smooth rotation and minimal friction. This automation improves efficiency, precision, and consistency in the production of ball bearings. Turning a brass alpha pen grip requires precision and efficient tooling. The process begins by securing the brass stock in the collet of the Haas ST10Y lathe. Use a coolant through 2.8 mm drill to create the initial bore, followed by progressively larger drills up to 1/4. This ensures accurate alignment and minimizes stress on smaller drills. Once the bore is complete, switch to a precision boring bar to refine the internal dimensions. Next, contour the outer profile of the grip using a turning tool, paying attention to the ergonomic design. For the tip, use the same tool to cut the final contour and part off the component in one operation. Although not standard practice, this method avoids the need to flip the part and remount it, saving setup time. After parting off, a manual deburring operation is necessary for the opening at the tip. Set up the deburring process on a Bridgeport or similar machine for efficiency. The SEMA SV hydraulic horizontal bending press offers exceptional capabilities for precision forming of large rings, such as those measuring 100 by 35 millimeters. Equipped with a hydraulic cylinder positioned beneath the table, the design ensures an unobstructed workspace. This setup allows for seamless execution of enclosed bends without interference from the machine frame, a limitation in conventional press brakes. Available in capacities ranging from 22 to 100 tons, the press is versatile, accommodating a broad array of tools for bending, straightening, punching, and shearing tasks. Its advanced hydraulic system delivers consistent force, enabling precise shaping of rings and other components. These features make the SEMA SV horizontal press an optimal choice for industries requiring efficient and accurate metal forming solutions.